write the next subheading as ICMP, Internet Control Message Protocol. Internet Control Message Protocol. This is one I mentioned earlier, that error reporting, when there is a problem with the delivery, errors will be reported using this. So this is also a layer 3 protocol, but although it is layer 3, it uses IP to travel. IP header is the header it uses. So layer 3 protocol using another layer 3 protocol's header to travel. So therefore we assume that the ICMP is slightly above IP because it can use IP, but it is not in the upper layer, it is in the same layer 3. Okay? So you can write, it is also a layer 3 protocol. It is also a layer 3 protocol. Layer 3 protocol. However, it can use IP header. It can use IP header, and therefore ICMP goes over IP. ICMP goes over IP. It reports errors. And also carries other control messages. Example, when a host is unreachable, an error is reported back to the sender. Back to the sender system. Similarly, port errors and protocol errors are also reported. And protocol errors are also reported. Therefore, it goes as short datagram which has following fields. Underline short datagram, it's not a long packet. We'll write down the 3 fields it have. Number 1, type. Number 1 is for the type. Number 2, code. Code. Number 3, first 8 bytes of the IP header first 8 bytes of the IP header that experience the error. That experience the error. So those are the three. This is the ICMP PD. This PDU will be encapsulated with the actual IP header and transmit. So there will be another IP header coming in front here to carry it. Internally it has an IP header which was the header which gave trouble earlier. So this is error recording. The IP header which was not delivered, which had a problem, is attached to the behind. So that is how the errors are reported. You can do that. These are the three fields: type field, code field, and 8-byte errored IP header. So ICMP is very useful error reporting protocol for routers. You can see the Internet protocol in layer 3, ICMP is just above, but it is not in the transport layer. ICMP can use the Internet layer. Transport layer protocols can also use the Internet layer. And normally ICMP has destination unreachable information, and also the ping command is part of ICMP. And there are others which I will give in the table next. So before we go to the table, we just try this idea. Where ICMP is actually coming. These are the most popular commands. Most popular commands. You would have used this, I'm sure. Sometimes when you send something, a message comes back saying destination unreached. That is the ICMP message coming. Also the ping command we normally use is also called the echo command. You type ping and the IP address, and that ping command is carried by the ICMP protocol. We said there are three fields. One is the type, other is the code, third one is the errored IP header. Type and code, there is a combination, a set of types and codes which are given in a table now. So let us draw the table, try to understand the table now. Like this. You don't need like this. This is the type. and the port. And what it means, when type is 0, there, port is also 0, that means the ping command. When you ping, that's the command, it will be sent. Type 340 means destination network unbreakable. This two are most popularly used. When you send a IP packet, but if one router finds that it is not possible to send it, if you send the IP packet back to you, saying that, okay, I could not send it. That destination unreachable message coming back. Then 3 and 1, destination host unreachable. 3 2, destination protocol unreachable. That means upper UDP or TCP did not accept it. And number 6 or number 17, I think, is unreachable. So likewise, lots of commands, lot of information carried by type by the port.
So UDP, TCP again array port close color with the degree of time.
That's why it says unreachable. You know, the ports are sometimes closed by security application. They don't want the ports to be kept open and you are not used. So they close. Suppose the packet comes, it is received, but it is not collected by the upper one because the port is closed. So then the ICMP message will have to be sent back, saying that the port is unreachable. Then you know that it went to the other machine, but the port is closed. Sometimes this is used by, this command itself is used by people, hackers. They call it port scanning. They try sending this to find out which are the ports open. There are software called port scanning software. When you run that, it will send these packets and get the reply. And when you get a reply that it's unreachable there, you know that that particular port is closed. So in order to check the security, before they hack, they have to find a place, find a way to hack. They do the port scanning to find out which are the vulnerable ports to attack. Shall we prepare the table? You don't need to remember a whole table, but it will be expensive because these are very commonly used. Information in the internet usage. normally the router receives the bad IP header. Checksum is not correct. It discards the packet but send to the originating host that I received bad IP header from a packet from you. Just to inform, that's all. It will not try to recover, just to inform. TTL expired, the particular router will find TTL is 0 and it discards. But then it sends the ICMP message back saying, I got a packet, but TTL is expired, so output is wrong. And when it goes back, the sending party will know what happened. And this is also very popular. Destination host unknown. To type an IP address for host name which is not there. Suppose the domain name service could not find it. Then you get a message back saying re-enter destination host unknown. On your screen you get host unknown. So unreachable. Then ping command, ping reply. So these things are very popular applications of ICMP. And it's a very small protocol also. Very small, few types of combinations are allowed, but heavily used for informing, right? You can write the table used physical errors reported and their error code. Physical errors reported and their error code. ICMP is used by host, comma HOSTS host, comma router and gateway to communicate network level information. Such as error recording and echo request. Echo means ping, right? Echo request / reply. Echo request / reply. So underline that sentence. That's the main sentence which use the capability of the ICMP protocol. Name for error reporting and little bit of control because you can type echo command and get the reply. That is the control mode. However, you can write ICMP PDU is encapsulated by a IP header. Encapsulated by an IP header. Before sending. That means you need the IP, otherwise ICMP alone can't do anything. And echo command is, how many of you have not used echo command? Everybody have used ping. When you are in a network, in order to find whether you can reach some other host, you normally type ping followed by that IP address. I think everyone of you have done it, right? Anyone who has not done it, I am not in a network, so I can't really show it, but I can show the ping command. So to go and select the run, and there are various commands you can type here. One of them may be, I have not typed in point. So type ping and then the network address you use. This is my IP address in the concept. It will not ping anyway. Right? It is not answering. I am not in the same LAN. You can see ICMP message being a reply. It will try 3 times and close. So now you know destination host unreachable is this. So that means I have got an IP packet with this code, ICMP with this code. It is not reachable now. So my LAN card will try. You see that message is come. It's sending a 32 bit address in IP packet. It tries to send it out, but it is not connected, and immediately reports the ICMP error message. Even if I am connected to a network, I might get the same thing because the network may not have this computer. The ping command is very useful when you have to check whether a computer is reachable from your computer. Check whether you are now connected to the network logically. So you immediately saw these messages are actually coming from the ICMP. So that's all about the ICMP. It's not a big protocol. Next protocol we discuss is DHCP. Dynamic Host Configuration Protocol. Dynamic Host Configuration Protocol. In the exam we may be required to describe some of these protocols. That's why we are taking the small ones also, not only I. We all know what it does. If you don't have an IP address in the network, you can try to get an IP address temporarily by using this protocol. There are networks which have DHCP servers. So when you are in such a network, suppose you are not given an IP, permanent IP, then you have to first there is a 4-way communication process. The computer, say your computer, will be first sending a message, is there a DHCP server there? Because it may be a network where there is no DHCP server. Okay? Then if there is a server in that local area network, it will reply saying, I am here, I can offer you the IP address. Then it sends a request with your MAC address, it sends a request. The other one will allocate an IP address for you and send the IP address to your computer. And your computer will start using that IP address for all communications to the network after that. But these IP addresses are given on a lease. That means only for a period. If that period expires, IP address gets automatically disappeared. But supposing you need it for a longer period than what was given, you have to make another request to extend the lease. It's like renting something. You rent it for a period. If the period is over, before it becomes over, you have to ask for more time if you want it. Otherwise, it will be automatically taken back. You have to make another request again in order to get an IP address. So, where do we normally use DHCP? Wireless network, DHCP is very popular, isn't it? You can just walk into a wireless phone and put your computer into DHCP and it will try to access DHCP server through that network, get an IP address, after that use that IP address to get connected. But you might walk away without informing the party that they think that you are still using this IP address. That's why the timeout period, that's why the lease period. After the lease, automatically that will be back in the pool, that IP address will be back in the pool. So it's a way of sharing IP addresses for ad hoc use. That means for a short period, temporarily, you can make use of the IP address for a purpose. The server can, DHCP server can be programmed for the leasing. The administrator of the server can say, okay, this IP address is used for 10 minutes, 20 minutes. After that, automatically that IP address will be disabled from the example, then it will be taken back to the not only this question is in a internet, what do you call it, cafe, right? They are given the access with a token for a certain period. Automatically it expires. So maybe the administrator is programming there. Once you buy the token, DHCP address he can monitor. And after that he can remove the DHCP address from the table manually. So if you do not use all 15 minutes and you leave, automatically that IP address can be taken back by the administrator. DHCP can be programmed for it.
සර් ඉන්ටර්නෙට් SLT ප්‍රීපේඩ් කාඩ් වල එහෙම ඒ අර මාස 3ක් මේ වැලිඩිටි පීරියඩ් එකේ තියෙන. ඒ කියන්නේ එතකොට අපි ඉස්සෙල්ලා දාපු වෙලාවේ එතන අසයින් කරන ඇඩ්‍රස් එකේ 3 මාස 3ම තියෙනවද?
No, I don't think it's a different thing. If it is 3 months thing, it will be a different authentication. Not the IP. IP may be DHCP temporarily only for that session. It is not for that kind of a very long period. If a card is given for 3 months kind of thing, it will be a different authentication method they are using. Maybe application layer authentication, not the IP.
සර් IP එක අසයින් කරන්න එක දවසක යන සෙෂන් එකට
IP only for that session, one DHCP address will be given. Next session you might be given another IP address. It's not for long period. But for that kind of thing you can use it. You can use it for short period. Okay, we'll write. And what is the layer? DHCP what layer protocol? Diploma analysis. This is layer 1, layer 2, layer 3, layer 4, this layer. Protocols are everywhere. Right? DHCP is on the top layer. Right? Application. Basically an application section. Right? You can write. DHCP allow a host to dynamically obtain an IP address from a DHCP server. IP address from a DHCP server in the network when it joins the network. However, the address is given for a lease period. So when the period expires, EXPIRES expires, DHCP can be used to renew it as well. The DHCP server will then acknowledge and give a second lease period. Acknowledge and give a second lease period. New paragraph. This is very popular in Wi-Fi. It is very popular in Wi-Fi. Wi-Fi network, hotspot. Those are the public places where wireless is available. They are called hotspot. H-O-T-C-O-T. Hotspot. In the airports you find them. Hotspot, and other common network. Common network means other people can come and join. However, the disadvantage is that some applications need static IP addresses. For the host, static IP addresses for the host. Example, such as subscription services. So that kind of services may not work with the DHCP because other servers may be giving a service only for a static IP. So that is only disadvantage. Other than that, it makes the job very easy for the user. So he doesn't need to program the IP addresses all the time. So overview is that we will have four. Will be first requesting a message, sending a message for DHCP discover. DHCP discover messages is sent. That's a special DHCP server. The server will respond with DHCP offer. It will offer the service. Mentioning the time here. The DHCP request will go. And after this DHCP message is asking for help, asking is there any DHCP server here? That's the question we start. We should say yes, I am here, this is my request. I am so and so, can you allocate me an IP address? Acknowledgement saying, no, here is the IP address, this is the period you can use. Those are the four messages. So we'll write small short notes for each one. First one, discover means the client is broadcasting a message to the LAN saying, can someone help me? Is there a DHCP server here? Because I don't have an IP address. If the DHCP server receives the request, it will send this offer message saying, okay, I am a DHCP server, this is my address. Then goes the request. Request goes to that address. Another address will be allocated for you. Post that. You can write. First DHCP discover. This is an example. Destination, address, transaction ID. This is the ID by which you will get the reply over there. 644 in 10654 in 10655 in here. And this is the lifetime you have got. This is the address allocated. Likewise, these are the technical details of each one. Maybe it is going to go like this. Only problem is I have drawn it there in the opposite direction. This is the client and that is the server in the same place. Doesn't matter, right? Other than that, everything else will be selected. I will draw it like that, then it will be easy to use the value. Server's address is given as 223.1.2.5. That's the IP address of the DHCP server, which the client does not know when it comes. Let's first find that out. I do right, it can be SRC means the source address. Destination, DEST means destination address. Why source address 0000? So this first in this network, that's the idea of 0000. 68 is the port number of DHCP. Okay, we learned that in the diploma. 68 is the port. 67, 68. This is the source address, source port. Destination address, destination port. 67 and 68 are the port addresses used for DHCP. Then why is it 255, 255, 255? Because it's a broadcast. It's a broadcast because it does not know whether the server is there. It's broadcasting, hoping that the server will reply. So while drawing, try to understand each portion. website I have uploaded the software simulator. You can go to that link and you can simulate this and it will show you the process one after the other. So try the simulator. It actually simulates this message. And any details you think later necessary. It is stored as the port. Destination as the port. Then your IP address is made 000 because we don't know. Your IP address, IIS. Transaction ID is the ID number for this communication. Upper packet will come back saying source address is this because that is the address of the server. Source port is 67 and destination address is broadcasting again. Okay. Because transaction ID is there, it knows that it is for this computer. Then IP address has been assigned 223.1.2.4. This is the IP address to be assigned to this, and now it will reply with that IP. This is the assigned IP address. Lifetime given is 3600 seconds. The will go with all this IP address now. The message will be repeated and the acknowledgement will be done. Now the transaction ID is it is the acknowledgement. Failure for this period it is confirmed. You can write port 67 and new line. Port 67 and 68. Port 67 and 68 are assigned for DHCP. But we have drawn it a scenario like this. There is a network. DHCP server is there somewhere and arriving mobile client just gets connected over a wireless access point in this network to the DHCP server, build the IP address, use it, and after that you can wait. That IP address will be taken back to the pool. The DHCP server administrator can control the assigned time connection. You don't need to write the whole set of addresses, but just draw the DHCP server and the arriving client. All set of addresses you don't need to write. Remember, some wireless access points should have been drawn here, it's not drawn. the network and this. If your MAC address is yours, it will be there in the laptop. But logical address you temporarily delete. Instead that you can control. That's why we need two levels of address. You can now see. But without logical addressing, we can't do this. DHCP is very popular in especially that time. We go to control panel, network connection. These are networks I normally use. Right? I don't remember which one is this one. Look at the property. Go to TCP IP. Look at the properties we have for that. So you can see this. Obtain an IP address automatically. What does that mean? That means I don't have a static IP in that network. So it is DHCP. So this computer, after detecting that network presence, will immediately originate that procedure. Get an IP address and use it for a lease period. DNS server address will also be obtained automatically after getting the IP address. You need the IP address before you go to the DNS. I'm not sure where I have forgotten. Of course, I have put DHCP, but sometimes when I go to the university, I change this by typing my own IP address and subnet mask and default gateway. Then we make it fixed. So those are the cases where your computer needs encrypt. Right? So these wireless networks are always DHCP. So for the user, it is so simple now. He just have to put that dot saying obtain an IP address automatically. And this is the procedure which happens inside logically to the DHCP. Port 67 and port 68 have been allocated for this server. Okay, next one is called network address translation, NAT. It's happening NAT. Network address translation. Under what kind of situation do we use NAT? Normally when you are short of IP address, suppose you have very large network but only one or two IP addresses to manage, one or two static IP. So you can't afford to give static IPs to each and every person in your local area. So what you do is, you give private IP addresses from your own block, free block, and for the internet you will be using one or two available static IPs. And for that purpose you have to implement the NAT, network address translation, because internal addresses will have to be translated as external addresses when the request comes. When the replies come, those addresses will have to be translated back to the internal addresses to send it up to the requesting host. So that idea we call network address translation. Can right? NAT allow us to manage a large private network, with a few global IP addresses. In addition, it improves the security level. Of the heart. Level of the heart as well. Because hosts are not directly visible to the external internet, attacking them is difficult. It's a translated address that goes to the internet. Actual host is protected because of that. Attacking is difficult. New paragraph. Internally, host can be given addresses from a private block, from a private IP block. Therefore, internal management becomes easier. Internal management becomes easier. In addition, it is easy to change to a different ISP address. To change to different internet service providers. As well. Where do you say that? Because your internal set of addresses you don't need to change. When you change, say from SLT to another provider, you will get different addresses and you just change those one or two addresses for the new one. Internal addresses remain the same. If you have got a big block and you have allocated those addresses to everybody, when you change your ISP, everything must be changed. All internal IP addresses will have to be changed, but now you don't need that with the NS. You just need to change only the external one or two addresses, internal one are the same. In the diploma I gave you 3 address ranges for the private use. What are the typical ranges? 10 dots is a typical range. Class A address range assigned 4 addresses. Other one is 192 dot 248 dot is also there. Did I give 3 ranges? In the diploma it must be there. Or else shall we write down, put a stand and I write something. Following are the public IP blocks available. Let me find from the diploma question. Exact values will write. This is one. You may remember the explain. You have written it earlier. Anyway, we'll write again. In class A, 10 dot anything. You can use privately within your network, great. But outside the network, not allowed. From the class B, 172.16. From 00 to 3103. Class C, 192.168. 192.168. 00 to 25.6. When you are planning network, you can remember the So these ranges are available to you. You don't need to pay or you don't need to get it from IS. From class A, class B, certain portions are reserved. This is an example of address translation. End of addresses are given to internal computers. And this is the translator. And this is the port address 10.0.0.4, and this is an external IP address, public IP. So the datagram leaving must carry the public IP. Returns will also come for that public IP, then it has to be translated to the internal one and transported to take the table here, and we will draw the table immediately after this. First you can draw this overlay. Translation table. class C network here. Using your internal class A block, you are subdividing it into class C. And only one IP address available for you for outside. For all these people, only one IP. Now, do we manage? We have to prepare a table and see. can note down below. An IP datagram carries an SA source address, SA and a DA, SA and a DA destination address. So, sir, when a datagram leaves the network, when the datagram leaves the network, the net will change. Net will change. Suppose someone is accessing internet, IP packet comes and it is transmitted, and this address will be okay. Source IP. Because source address should be changed to this way. Destination is what you want to change the source IP address. To step number 138.76.2929.7. It is public IP, we change it to public IP. Remember that IP is an example on a new paragraph. For arriving datagram from internet, the net will change the destination IP address. Destination IP address to the correct private IP, private IP of that host. So, to do these changes, it uses the net translation table. Net translation table. Area network site address and the local area network site address. In this example, wide area network address is only one, but you can have more than one. You can manage with few. Therefore, you normally prepare a table. The table will be there in the net device here. Implementing the translation. Let us take an example. So this computer is sending a packet like this. Maybe you should draw it again. So it's an example with the value. So we are going to discuss what is happening in steps like this. Go with enough space in between. Step by step we will do. We'll see how the table enters these things. Okay? First, we'll assume this source was .0.0.1 is sending a datagram to external IP address of this for HTTP request port 8. Port 80 is sender. This is HTTP sender. HTTP request is to be sent out to this public IP address outside in the internet. That's step number 1. Destination port 80, but source port which has allocated is 3345. This means the source address same in the destination address. Other fields we are not writing, only the address field we are writing, right? Source and destination. But it's the IT packet. Now it arrives at the NAS and then it has to translate it and make an entry in the translation table. So when the reply comes, reply should go to the correct computer. Therefore it will convert it like this and make this entry in the table. What happens now? Instead of this source address, it will put this public address 138.76. That means the other host there, other server there thinks that it is this device sending the request. Translate, this is also translated. Port number also you can translate to a different value if you want, 5001. So you make an entry. This is the address and the port it used for this computer and this port. So IP address and the port address are combined to make an entry in the net pair. So when the reply comes, it knows to whom it should be given. Step number 2, next route it changes datagram source address to that public. The new port number is also initiated. be many other requests coming like this, right? For different servers and many entries, right? But in all of them, this may be the same. The only way to differentiate is that you have to insert a new port number for the other server. That's why the port number is also coming into this. Because it's not only the IP address, IP and port combination that you continue to change. So that when the reply comes, you can sort by this total length, total number. Total number is never duplicated. So reply comes now from the distant server. Reply comes as step 3. Reply arrives with this destination address. Destination address is this. It looks at the table, convert it to this, and transmit it into the local. Then in the local network, correct computer will definitely collect it now, because this computer's address comes back. So therefore, it will definitely collect. Reply arrives like that, it converts and sends into the local NAT. It converts from this entry of the table. It looks at this, takes it, and put it into the destination address and send it to the local. The local computer gets the match, therefore it's correct. And this can happen to all others. And simultaneously also many communications will be open. There may be many entries. I have shown only one, but there can be many simultaneous parallel entries. Do you understand why this port number was not sent? It could have been sent instead of 5,000. Why? Because there can be another computer who is requesting with the same port number. But then it may be requesting for a different application. Therefore, another new number is necessary to be generated there. That's why the port number is also converted, not only IP address. Although we call it address translation, you can see IP address is being translated, port is also being translated. Port is some new value, arbitrary value it generates, but it makes sure that it is a unique port for that computer. So you can write. The figure shows how an entry is made into the NAT table. So the port number is also used. Port number is also used in the entry. Since it is 16 bits, since it's 16 bits, 60,000 simultaneous connections can be made simultaneous connections can be made with a single LAN side address. Single LAN side address. New line. Security of the internal host is improved now. Because its IP address or port number is not visible to outside. In addition, internal address plan can be changed without informing outside world. Then just mention these comments. Next is controversial because it violates some rule. Next is controversial. Controversial means it violates some rule. Because it has following what do we say? If it violates, not violates, following variations from normal rules. Following variations from the normal rules. Number one says routers should only process up to layer 3. That's the normal rule. Router is a layer 3 device. But network address translation has the port address also changed. Port address is from the upper layer. Transport. That means the router is handling something from the transport layer also. Port address manipulating means you are not supposed to touch that. You are not supposed to touch the port address because it's in the inner head, not your head. But now router will enter those also into the table and change the port address. This is not normal. Because it violates the normal rules that router is a layer 3 device. However, it manipulates the port numbers now. So that's the little problem now. Also, second problem is violates end-to-end argument. End-to-end delivery is the upper layer system. End-to-end argument. Is in bracket. Only transport layers should do that. But now routers are also playing around with end-to-end delivery. Originally, when we studied the ISO layer, we said end-to-end delivery is a problem for the upper layer, not for the router or the IP. But now here it is also being done. That's done. Now the problem here is address routing. It has to be corrected by IP version 6, not by NAT. The NAT is only a temporary measure. We will say road instead of saying ROADS. Road should be solved by IPv6. Road ROADS should be solved by IP version 6. IP version 6, not by a technique like NAT, not by a technique like network address translate. So what are the solutions for roads now? Solutions for roads. Everything we did today are solutions for roads. What are the solutions? Variable length subnet mask is one part of the solution. What else? DHCP is another part of solution, because temporarily you can leave for a period an IP address and take it back. You are not permanently allocated. Another solution. Third one is NAT. Okay, so examiner's question could be, with the classful addressing, there is a problem called road. He might ask, well, what are the solutions available? You must be able to list. You should be able to say the permanent solution is IP version 6 with the 128-bit address space. That's the permanent. Then you have to say, however, until IP version 6 comes, we need temporary methods. Following are the temporary methods. What are the methods? Everything we did today. Variable length subnetting, DHCP, NAT. Those are partially solving this address. Not enough addresses are available. That's why all these techniques have come. So each one will contribute to solve the problem partially until IP version 6 really comes into usage. So that's why we did this. Now try to get the whole idea, right? Although we did several things one after the other, they are all related with one problem. What is the problem? Running out of address space, the road stuff. Examiner's questions may be targeted to road, so be aware, right? Next week we have a holiday because of the poet. Poet comes on Saturday. Week after that we will run in a normal way, right? This is time for cramming, right? Cramming or holiday, whatever you do. So don't come next Saturday, right? I know that some of you will come anyway. It happens every time. When we do a holiday, on that day, please give me a call. Okay, so there are few students here. What do I do? Hope that will not happen this time. So in 2 weeks' time, we'll meet on Saturday. Thank you very much.